Good morning, everyone. Cluster is ready. And yeah, so till now we discussed almost each and every resource in Kubernetes, that is pod, config map, secret, and then service sets inside the set, replica set, deployment, daemon set, and then stateful set. So yesterday we have discussed static and dynamic provisioning. So out of this, we have three important things, that is storage class used for dynamic provisioning, and then PV, so physical representation of external storage, and PVC, persistent volume claim. So it claims that pod can make to mount the volume. Okay. So and yesterday we discussed stateful set versus deployment as well. So as the name suggests, stateful set is for database applications. Stateful set is for DB applications. Okay. So it keeps the network identity like name same. It uses headless service. And you know why it uses headless service? Because once it gets the update, it can send all the updates to the each and every node in the cluster. But deployment is completely different. It is stateless, will not keep any identity, it will use normal service. Okay. So we have a few databases as part of our RoboShop. Then we are going to keep them as stateful set. Just creating K8 databases. So inside that, MongoDB. Okay, so which one I have to use, EAPS or EFS? Okay. So for databases, we have to use EBS because it's an elastic block store. The characteristic of elastic block store is it is near to the server. Right? EFS, it is somewhere in the network. So database applications, EBS is the most ideal solution because it sits next to the server and the latency will be very less. If you select EFS for the database, then it will not, it is not good because it is somewhere in the internet. The latency between the server and the database will become very high. So we have to obviously use EBS for our database applications. So, you know, we are going to use dynamic provisioning. Use dynamic provisioning. Okay. So now let us configure MongoDB as stateful set. Okay, because deployment is not suitable for database applications. And now what are the steps? First, install driver, VS CSI driver. And second one, give access to EC2 servers. Okay. And then creation of storage class. So you need to note a point here. Storage class creation is not depends on application. Okay, it is admin activity. Completely outside of application manifest files. Okay. So once this is done, these are all admin activities. Okay. Once this is done, so admins will inform us everything is prepared. So you can start using. Then we can create PVC and mount to the pod. Okay. So this is the process. Now let us do that. EBS CSI driver. Yeah. So the pod. So these are the drivers. Drivers are installed. And the second step, give access to EC2 servers. Just go and select the role, attach policies, to full access. So this is done, and creation of storage class. So as I said, this is admin activity. I will keep it outside. EBS dynamic. So EBS not in MongoDB. I want to keep it outside. EBS dynamic sc.aml. So yesterday we have created this create resources, storage, and EBS dynamic. So this one. You have to keep it always outside. Otherwise, each time we will delete and that will become a problem. Okay. So this is the one. And so I will just give shop EBS. Shop dynamic EBS. Okay, so this is the storage class. And now inside this, we need to give our manifest.aml. First, let us create this storage class. I'm just creating another repo, K8 databases. Public create repo. It remote add origin. So we got this. Now clone into the server. The 8 databases. kubectl apply -f EBS dynamic SC. Okay, storage class created kubectl get SC. Okay, storage class created. Now we need to create our stateful set. So let me take the example. Sets stateful set. So we need to change here. Name is going to be MongoDB, and then selectors can give labels here itself. Name, can say app MongoDB, and then database tier, project, RoboShop. Just selected maximum label so that it will not clash with other projects. So I will give this everywhere. So service name is going to be MongoDB, replica 1, and these are the templates of the pod. Okay. Containers is going to be join DevOps slash MongoDB colon 1.0.0. Just let me check whether the image is available or not. From DevOps MongoDB 1.0.0. Okay, it is available. So this is going to be the image. And you can just name it as MongoDB. Ports now. Now this is important. Volume claim template. So we need this name. I'm going to just keep it as MongoDB, and storage class name. This is the storage class name. RoboShop Dynamic EBS. And we need storage of 5 GB. Okay, so this is the direct PVC. So this one I'm going to keep it here. And then MongoDB, it is going to be /data/db. Okay, so we need to mount here. Okay, this is the stateful set. Now coming to the service. So this is going to be, name is going to be MongoDB. And then, the port numbers generally. labels, match the labels. Cluster IP should be none. And the ports is going to be MongoDB port 27017. Target port also 27017. The target port is nothing but pod port, pod or container. Okay, so this is the MongoDB stateful set. So let us push and then pull. Ed MongoDB kubectl apply -f manifest.m. Okay, getting created kubectl get pods. Let us see what is also getting created, and you can see the name is something different. MongoDB -0. So let us see the volume got created or not. I'm going to delete the unused volumes. Okay. Keep an eye on the volumes because we are doing it dynamically. Sometimes we forget. So we created 5 GB just now. That is this one. Okay. So MongoDB is running. The next thing is kubectl get svc. Okay, MongoDB is running. And then next, we just run. Let us just test this MongoDB is running or not through our catalog. If that catalog is able to connect, then we can confirm the MongoDB is running properly. Okay. So for that, I will just clone K8 RoboShop. Here we have catalog one, right? So it clone. Things already exist. K8 RoboShop. And then catalog. So let me check the manifest once. Fine. So kubectl apply -f manifest. Okay, it is using RoboShop namespace. Okay. Just for temporary purpose, I'm just removing this namespace RoboShop. Just testing whether this is or stateful set is working on kubectl get pods, kubectl logs. You can see MongoDB connected. So stateful sets are working. Now let me create the stateful set for other applications. Just copy paste. That's it. Redis. Manifest.ml. Okay. So Redis, we are using the image from the internet. Redis. So instead of MongoDB, I'm going to keep Redis. Image is going to be directly from internet. Redis. Okay. And then all you want Redis. What is the Redis data folder? It is just slash data. And this is Redis. Service name Redis app, Redis port 6379. 6379. Okay. Yeah, that's it. I just run. Just check once again. No MongoDB. Push full Redis full CTL apply -f managed. CTL get bots. Okay, Redis is run. That's it. Very simple. Everything is copy paste now. And then MySQL, same thing. So instead of MongoDB, going to create MySQL. The MySQL is not our own image, so we just did something. For MySQL, the data directory is going to be where lib MySQL. Okay. And this is the and port number is 3306. 3306. And MySQL needs some configuration for us generally. So we need to keep config map. Okay, troubleshoot MySQL manifest, and this is the config map. And to use that config map, we need to write the syntax here, right? So inside our stateful set, and here, env from config map reference, and then here we just mention MySQL. Okay, that's it. Push and pull. SQL kubectl apply hyphen f manifest. Shit. Watch kubectl get box. MySQL is also getting created. Now RabbitMQ. Rest.ml. So instead of Redis, it is going to be RabbitMQ. RabbitMQ data folder is going to be just like MySQL, where with RabbitMQ. RabbitMQ, 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 and the RabbitMQ port 156756728. Okay. Does it need any configuration? Address check. Configuration. kubectl apply hyphen f manifest. Okay. So now all databases are ready. It's a simple example when you are practicing. Make the other apps also ready through deployments and then access the application through the browser. Okay. Yeah. So this is about storage and stateful set in Kubernetes, important concept to the interviews. So next thing we will discuss something called Helm charts. So in this entire Docker and Kubernetes, we are doing two things only. Just remember, we are doing two things. One is building and pushing image. Second thing, manifest how to run the image. Okay, so inside this manifest, we are writing deployment, service, config map, many things. Okay. Just tell me something. Let me take the catalog. So what are the frequently changing things here once the application is going to release new version? So what are the values can be changed here? Please answer in the chat. So do you think all these things will change? These things will be frequently changing or mostly static? Just for this question, these things are going to be changed or mostly static, right? So only thing that changes for every new release is this one, only image version. So if you see this entire manifest file is going to be mostly static, except this image version. Okay. So anyhow, we will do this. We know how to do this. Whenever there is a change in version, we will just do the Docker build. We will just change the version name like 1.1.0 and then we will push it. But manifest, we need to input latest version. So now overall, if you see, if you set up this application one time, then it is mostly nothing. You just change the image and then apply manifest. Change the image, apply manifest. So building and pushing image, this can be done by through CI. This is also automatic. We will do this anyhow. Okay. So once the full application is set up, at least for first time, from the second time, that is going to be very easy. You just need to change the image version and apply the manifest. That's it. Okay. So the general thing, not only in DevOps, anywhere, what we do is we will keep the important files aside and edit only required fields. Okay. So if I come here and edit directly, there is a high chance I do mistakes over this file. What is the concept of variables? The concept of variables is try, don't repeat yourself. And another thing is without touching main files, we will send parameters, right? So now let us take this one. Let us go back to shell script. Which one is preferred? Person equal to 1 or another one? This one is preferred. So which one you prefer? You want to keep the value. Okay. So here also it's common. Okay, so there are two things in shell script. So I have two ways to create variables. One is directly in the script. Okay. Name equal to script mark. So this is first approach. And the second approach is this one. Which one you prefer, first or second? So why second approach? Because you have to go and then change in the file manually. So that is not a problem. But while changing this, there is a high chance you do mistake accidentally. Okay. You may give space here, or you may edit something else by mistake. So that is why we will avoid touching the files most of the times. So we will keep the configuration out of the file and we will change it. So that is the overall concept of everything. Variables, config maps, secrets, everything. That is the concept of without touching the main files to keep the configuration outside and then change it. So here also, this is the important file. Just for a single value, if you come here and then changing every time, that is not good. That is not recommended. So for that purpose, so we have something called Helm. So the purpose of Helm is two things. One is parameterize the Kubernetes manifest files. And the other purpose is it is Kubernetes package manager. Okay, second point we will understand. First, let's concentrate on the first point, parameterize the Kubernetes manifest files. So first, let us install Helm. This is going to be the easiest concept of Kubernetes. Docs, fix. Installing Helm. Very simple, just 3 commands. Then this one. And this one. Okay. Helm version. Okay. Helm is installed. Now here, I'll just write something. Helm charts. So this is going to be the easiest concept of Kubernetes if you understand the purpose. So this is going to be the structure. So out of this, let us discuss on the first one, chart.yaml. Okay. So this is the mandatory file you should keep here, chart.yaml. And inside this, you have these are the options. So API version, just like Kubernetes manifest in chat.yaml also API version is important. So that is this one, and it is required also. It is the API version. So that is going to be the V1. I think it's going to be V2 because here they mention V2 for the Helm charts that require at least Helm 3. So now we are working on Helm 3, right? So we install Helm 3 now. That is going to be the V1. So they mentioned here V2. So I'm going to keep it here as V2. Okay, so this is the API version and the name of the chat. For example, let's work on something simple thing that is Nginx version. What is your chat version? This is the chat version. Okay. This is the chat version. I'm just going to give 0.0.1. And the other important thing is optional description. You can just mention something useful. So this is the Helm chart of Nginx. Okay. Type is optional. This is optional. Everything is optional. This is just metadata. So this entire chat.yaml is the metadata of your application. Okay, right now we selected Nginx. You can just give who are maintaining this and this. That's it. So generally this one app version. App version is going to be our application. Okay. For example, 1.0.0 something, just for simplicity. Like catalog version. Okay. So this version belongs to application. Okay, so these three are mandatory because we need to give some name to our chat version, and then this is API version. Okay, so this is the metadata of our chat. So mostly same in everywhere. And after that, templates. So this is templates and values. So this is going to be important thing. So how the structure should be, it is already mentioned here. You should have a directory, templates. Okay, create a directory here, templates. So inside here, so this templates folder is where you are going to keep your manifest files. For example, deployment.ml. I'm going to keep my Kubernetes deployment here. I'm just giving replica as 2. So Nginx deployment, and then label app Nginx. Just let me give this one. Yeah, everywhere it is given same. So this is our Nginx deployment. I'm going to create another one, service.aml. Okay, so let me take that as well. And I'm going to give type as load balancer. Okay, just for our testing. To make sure everything is this. So we have anyhow the image is already available in the internet. Nginx image is already available in the internet, and this is the service. Okay, so now how to run this? First, let me create the repository. Helm chats. Git clone the Helm chats. Yeah, we have chat.ml that is important, and templates. So these two are mandatory. Now let us just see the commands, how to install the chat. Helm commands. This is nothing but Helm install. Install. Helm install and name of the chat. Okay. Let me check some example also. Helm install and name of the chat. So what is the chat name here first? C should be caps, okay? Helm install Nginx. And then you have to give a name dot. Helm install this is the name and this chat. Right? They connected one. So URL should be install. This is not going to be URL. This is error. I think we should give some name. Error NG minutes. Okay. Okay. So this dot means, so I'm informing Helm that chat.aml is in current folder. Okay. So Helm input is chat.aml. Just like Docker file should be exist in current folder, chat.aml should exist in current folder. Okay. So now the command is helm install. What is the name of your? Now it is install. So install means what? So it installed. So it have gone through these templates and then ran these two files, deployment and service both. Now if you see kubectl get pods, our Nginx is running. Okay, so whenever you install the chat, what it is doing, so it is going to the templates folder and it is applying these manifests automatically. Okay, so that is what it is doing. So now this is not the advantage of Helm, but actual advantage is in the values. Okay, so values, how it should be, the file name is here, values.am. Okay, so now here comes the parameterizing the manifest. Now, as we discussed, what is the changing thing here? Image version, right? So what is this image version? Here I'm going to keep the image as parameter and then I'll submit the actual image at runtime. Okay, so here the syntax is going to be, you can just check templates and values. Okay, so the syntax is going to be double braces, close this, and here dot values, give space, dot values, dot, I'm going to keep here deployment dot image version. Okay. So this is what I'm going to keep it. Now inside this values, this dot values means it is going to refer values.ml, be small. Here I will just give a section deployment and then image version. Okay, now I'm going to change the image version. Let us just check what is the image version available. Right now it is latest. Just understand, I'm going to upgrade the release. Now I'm going to use this one, stable per. Okay. So ideally you can parameterize anything here. For example, let me parameterize the replicas. So what is the syntax? Double quotes, braces, capital values, dot, deployment, dot, replica count. Okay. So you don't need to make the sections. You can directly keep values dot replica count. So in that case, it will become directly like this. Replica count. You can make like this as well. For example, like this. You can do like this, but why I'm not doing this? If someone says this values.aml, so they will understand. So this replica count is part of the deployment manifest. Okay. That is why I'm going to give here. And then inside service, actually there is no need to parameterize anything. Okay. For example, you can just parameterize this one just for demonstration purpose. Values dot service dot port. So here you need to create one section service and then port 80. Okay. So now let me push. So you change the application version. I mean the image version. So now you need to upgrade. Just refer the commands here. Helm upgrade, name of it, and then dot. So Helm upgrade. What is the name of the chat? Nginx dot. Now you can see a revision 2 has been applied. Earlier revision 1 was applied. Now if you just see kubectl get pods, 3 pods should be running. Oh, I didn't pull it, sorry. Git pull. Okay, now you can just upgrade some errors here. Upgrade failed. Cannot patch Nginx service with time service is invalid. So this saying something replicas. Some problem with our numbers. Just let us keep this in quotes. Okay, now push it pull. Now apply. Same. Is there anything wrong here in our manifest? Okay, so maybe for values, we should not give this one. I mean for numbers. Yeah, now it is 10. Now if you check kubectl get pods, now you can see it is getting upgraded to the new version. And we are going to get 3 replicas. kubectl get deployments. Now you can see 3 by 3 available. So it means everything is worked. So practically in our projects, we are going to use Helm chats. Okay, so we will keep everything inside so that you no need to touch again and again one time if you set up, and then you just apply that. You'll get your application upgraded. So another thing, for example, something wrong. Okay, something wrong with the current release. How can you easily revert back to the previous version? Just imagine you release the latest, your latest release is done. After half an hour or 1 hour, you found a serious defect in your system. So then what you have to do, you have to roll back to the previous version. So then in that case, Helm history, and then this history command. Helm history, and then your chat name, Nginx. Oh, what is this? What is this history command? Yeah, that is the correct one. This I can put this clear Helm history Nginx. Something is wrong. I'm taking new login. Helm history Nginx. Huh. We're getting the output, but see this is the output. But unfortunately, we are getting something this error also. That is gone. We already upgraded. Why again? Okay. Helm history command. Is correct. Yeah, we getting it's already up to date. Helm history Nginx. Wow. So this is the one actually. This is the output I require. And then so this is the another one. Something wrong with this format. I'll just make this here. So this is one. And then the second is this one. And the third is this one. Oh, yeah. So this is because when we did some upgrades, so we got some failed response, right? So that is this one. So what it is saying, so the third one you tried, it was failed. The fourth one you tried, it was failed. And the fifth one you tried, now it is deployed. Now is the running one. Status deployed means this is the running one. Now I want to roll back to the previous version of revision 1 or 2. Okay. So yeah, first let us do one thing. Let me delete this chart. Help, delete engines. Okay, so this is done. Now if you give helm list, nothing is there. Okay. Now I'm going to do helm install nginx dot helm list. Now you can say nginx is done. Now what I do, as part of my application release process, I'm going to upgrade this to the latest one. Okay, and I'm going to give five replicas. Push. Pull. And then helm upgrade nginx dot. Okay, now you helm history nginx. So now the first version was done. Now I recently, just now I upgraded to the latest version. Now after half an hour, I found this one is giving serious defects. Application is going to down, business is going to down. We need to immediately roll back to the previous version to save our business. Then in that case, helm roll back, just helm roll back, and then nginx. That's it. Then it will immediately go back to the previous version. Now, if you just check the history, the third revision is created, and then you can see here roll back to the one. Okay. So this is how it is useful in CI/CD process. Okay. So you will deploy the application and then you will just do a simple check like health check. And if it is working, then you will keep it. Otherwise, you will immediately roll back it. Okay, so we will try this with our RoboShop also. Okay, so the whole setup. So we are discussing concepts and then ultimately we are going to apply this on our RoboShop with CI/CD. Okay, maybe in next week. We will build the images, we will push to the Docker Hub or ECR, and then we will automatically update the image version and then we will deploy the application. Okay, so we have few leftover concepts in Kubernetes. We will discuss them and then parallelly we will run our project. Any questions till now? The one purpose is done. So another purpose is parameterizing the Kubernetes manifest files. This we are using. Another purpose is Kubernetes package manager. So what is package manager? Just like this one, yum install nginx-y. What is happening in the background? Fetching the nginx package from internet. We don't know, somewhere it is, and then install in our server. Okay? So these are the things happening as part of any installation procedure. So for us, with respect to the Kubernetes, what is the installation? Fetch image and then run manifest. So this is the installation, right? So how I'm installing catalog or MongoDB. So I'm fetching the image from internet like Docker Hub, and then I'm running the manifest. So this is the package, installation of package. That is what happening in every package installation. Or you download, you install VLC media player in your computer. What you do, you download the package, you'll do the installation. So installation is nothing but configuration. So here, download the image and run the manifest. Now I want to install Elasticsearch into my Kubernetes cluster. Okay. Elasticsearch or Prometheus, for example. So what is the general way? First thing, image should be available. Okay. And the second thing, you should know how to create and run manifest files. So obviously this is third party. Here, I'm not developing Nginx. So I'm not developing Elasticsearch or Prometheus. So those companies develop and then pushed into the public internet. The images available in internet. And if you refer the documentation, their documentation, they will tell you how you create the configurations, how can you run the deployments, all those things. Now what Helm is doing, Helm have some chats, for example, Helm public chats. Artifact Hub, for example. Here, if you just check Prometheus, so on behalf of you, they developed everything. So they developed all the manifest files. What are, is it deployment or stateful set or config maps, whatever the resources required for to run that Prometheus successfully. Just understand, we need only two things: image and then how to create and run the manifest files. So I don't know Prometheus actually. I don't know Elasticsearch. I don't know how to configure, but there are manifest files in the internet and there are images in the internet. Helm can mix them, Helm can fetch the image, and Helm can run the manifest files. If you just see this here, you need to add that Helm repo, add, this is the Prometheus URL. So ultimately, when you are installing Nginx also, it should fetch the package from somewhere in the internet. So the same thing is happening here. You are adding Helm repo. So this is the repo name and this is the URL. Okay, and you are just updating this, just like yum update. And now you can install Helm install and release name. You can just give any name you want. Okay, now let me do this. Helm repo add. Or else let me give you one of the example we already used. We will come to this later. Now I want to install EFS drivers. So we have, you see, here we have two options. You can see. So these drivers, nothing but, so there will be some pods, some config maps, some services, some deployments. We don't know what are all those things as part of drivers. Okay, I really don't know what are drivers. No, and we don't need to know also, but we need to install them. So Helm is giving Helm repo, add this AWS repo, and then just run this and install this one. Your drivers will be done. Now let me do this. Now, if you just type Helm repo list, so we have this repo, AWS repo, and this is the URL. Now, if you just update this repo, you will get the latest charts. Okay, just like yum update, yum repo add, we will add the repo, we will update it, and then we will install it. Okay, it is installed. You can just check kubectl get pods -n kube system, or now you can see EFS, everything is installed. So Helm is used as package manager. You can install third-party applications into Kubernetes cluster like Prometheus and then Grafana, whatever. Okay. So now I'm going to delete our manifest files. Okay, I'm going to delete everything now. Today we can end here, and from next week we'll club everything and we will run our project file. Okay, cd mongodb kubectl delete -f manifest and Redis delete manifest, and then just RabbitMQ delete manifest, and then MySQL delete manifest. Okay, and Helm can delete them. Helm delete Nginx. Okay, and we still have something from kubectl delete deployment catalog. Kubectl get all. We still have some load balancer. Kubectl delete SVC Nginx service. Not found. It's already deleted. Kubectl delete this one. Okay. So now everything got deleted, and make sure you remove the volumes also, at least available volumes. Because this will not be deleted. Because data is important. That is why we are not deleting automatically. And then I don't know where this one got used. Okay. So these are from Jenkins workstation. Oops. Now you can try Kubernetes EKS CTL delete. Before I delete, let me have some questions. Yes, Aravind.
Uh, Shiva, hi Shiva. So can
Yeah,
you
hi.
go to VS Code, Shiva?
Okay.
Okay, so my question is instead of so manifest rights files can be directly written on Helm charts.
Yeah. So these are manifest files only. Just you are parameterizing it.
Okay, so directly I can parameterize, right, when I'm doing for a new project like
Directly parameterizing means what? How?
s- so I
Okay.
create the templates and values.
Hmm.
Uh, so say for example, I have a new requirement of a project.
Hmm.
So for writing the manifest files, I can write on the Helm charts with subfolders of templates and values, right? So that instead
Yeah.
of
So these are manifest only. These are not Helm charts. This is manifest only. Only one extra thing you are doing through Helm is this one only.
okay, yeah, got it.
That's it. And you need this one chat.m. So this is again manifest files. Only you are using Helm to have this kind of things. Okay.
Yeah, no, understood. Yeah, thanks, sure.
Yeah. Any other questions from anyone? Okay. So if no questions, have a nice weekend. See you in next week. Satish Kumar Chillapalli. Yes, Satish Kumar Chillapalli. Okay. So that's all for today's session. Have a nice weekend. See you next week. Bye.